Well, hello, my name is Max Cordry. I'm a rising senior at the University of Kansas studying chemical engineering, and this is what I've been working on for 3P processing through K-State's Pollution Prevention Institute. So first, a little bit of background about 3P. They were formerly known as Next Tech Processing and founded in 1974, and they currently serve 18 original equipment manufacturers across 36 states. And they have about 170 employees at their 111,000 square foot facility in Wichita, Kansas. So 3P processing is what's known as a processing or job shop. They are one of 5 in the city of Wichita. And what these companies do is they don't manufacture or even own the aerospace parts that are coming into their facilities, but sometimes the machine shops that do make the parts run into processes that they either can't or don't want to do. So they will hire job shops to do it for them. And as you can see, based on these numbers in 2019, there's a myriad of parts that 3P has to deal with in a given year. And often these parts are so unique from each other that they have to spend at least a day planning the complex process that each part is going to have to undergo. The company doesn't have any explicit environmental goals, but they have plenty of reasons for wanting to pursue some pollution prevention or P2 measures. They're aware that their facility produces several waste streams, such as water waste, solvent waste, and especially paint waste. The reason why the paint waste is such a concern is many of the paints used at 3P contain some fairly nasty chemicals, whether it's hexavalent chromium, like carcinogen, hazardous air pollutants, and or volatile organic compounds. So that means any waste paint that gets generated, as well as items contaminated with the paint, have to be disposed of as hazardous waste. And profit margins in this region of the aerospace industry tend to be fairly slim. And because parts, if part of the process goes wrong, it usually has to go through the entire process again, regardless of where the error was. Rework can get pretty expensive pretty quickly. So here I have a brief summary of the 4 projects that I was able to work on during my time at 3P. The paint transfer and process tank covers were more directly related to the waste stream elimination or reduction. And while I was working on those, I noticed that there might be a couple other ways that 3P could have some environmental and economic savings in the forms of an LED retrofit and the repairing of some compressed air leaks. But by far the most important project for 3P was the paint transfer project. So as I mentioned before, each part has to undergo a complex process that involves multiple steps, meaning there's multiple places where things could go wrong. The number one area where it will go wrong is during the painting of the part, because the stringent specifications require the parts to have a uniform coating thickness. And on complex parts like that can be difficult to achieve. And when a part's painted incorrectly, the coating can't simply be touched up. The entire coating has to be blasted off, and that creates a significant amount of paint waste, both from the paint that was used erroneously painted the first time and the material you're removing the paint with. 3P tracks how many parts get rejected, as well as the approximate cost of reworking those parts. And analyzing both the quantity and cost of that, I found that on average, errors related to the painting are responsible for about 2/3 of all the rework. But that's not all, because as I mentioned before, 3P has to blast off all that paint and repaint the parts, and that creates a lot of paint waste. Looking at some waste manifests and purchase orders, I found that on average, about 98% of the quantity of waste had something to do with the paint. And the cost of disposing of that waste, about 75% of that was made up with paint waste. Unfortunately, there's not a clear-cut insert paint transfer formula or formula available that I could use, but there is the P2 mantra, which focuses on eliminating or reducing waste streams by looking for ways to change the material, change the technology, and change the process. So using that, I was able to come up with a few different approaches for this complex problem. The first approach I looked at was, well, would it be possible for 3P to use less hazardous paints? They currently use 250 plus paints at their facility. Some of them cost $1,000 a gallon or more. And as I mentioned before, a lot of these paints contain some toxic chemicals. But unfortunately, the paints used are specification driven. So 3P doesn't have a lot of say in what paints they get to use on their parts. The reason why we still use these hazardous paints is because they offer some pretty nice corrosion protection. And you definitely don't want your airplanes corroding with flight. So until the aerospace industry can find some suitable alternatives, there's not a whole lot that can be done to change the material. Then maybe we could change the technology, and I focused on looking at the spray guns that are used to apply the paints. Most of the spray guns at 3P are the high volume, low pressure or HVLP type. They have a transfer efficiency about 40 to 50%, so not bad. And that just compares the amount of paint you're spraying to the amount of paint that actually makes it onto the part. But after doing some research, the general consensus seemed to be that electrostatic paint guns tend to be the most efficient with a transfer efficiency around 85%. So that's at least a 35% increase. However, there's a few other things that have to be considered before electrostatic guns can be used. As was seen briefly on the previous slide, electrostatic guns work by giving the paint an electrical charge. And if you charge the metal part you're painting with the opposite charge, the paint will be attracted to the part, and that will increase your transfer efficiency. But a lot of the parts before they're painted get anodized. And while that helps to protect from corrosion and improves the paint's ability to adhere to the parts, it also reduces the metal's conductivity a little bit. So getting the metal parts charged might be difficult, if not impossible. Electrostatic guns also tend to work better with processes that you can automate. The traditional way to charge the parts is you'll have an electrified conveyor belt going across the ceiling, and you'll just hang the parts from that. But as I mentioned before, there's such a sheer variety of parts that 3P has to deal with that automation would be very difficult to implement. And even looking at some of the paint specifications, there are even some paints that explicitly mention don't paint this with electrostatic paint guns. So 3P would not only be unable to make a complete conversion to electrostatic paint guns, they'd have to train their painters which paints should be used with which guns. And I thought that this would just overcomplicate the process. I did, however, have some success looking into changing the process, specifically the way that the painters are trained. So during my time touring the paint booths, I learned that most of the new painters receive their training through hands-on, on-the-job training, or OJT. They get paired up with an experienced painter who shows them the ropes of painting. Unfortunately, there are many experienced painters who do this, and they all have their own techniques, which means the new painters are learning different techniques, and that causes a lot of confusion and distrust between them. I've heard that the incoming shift of painters will not use the previous shift's already mixed paint for fear that they did not mix it correctly. So they'll go get their own paint, mix it themselves, and it just creates more paint waste. I wanted to be sure that this is the only way that painters are trained, and I found that 3P did have a decent amount of training material, but a lot of it seemed to go unused. Some painters, when I showed it to them, didn't know it existed. And it definitely shows because while I was in the paint booths, I noticed there were several improper painting techniques. So all of these provide some strong incentives to seek some improved painter training. And also, there is some evidence to suggest that painter training can help reduce turnover, because the turnover rate for painters has spikes, not just for 3P, but for most of the aerospace industry, from what I've heard. So I reached out to the Iowa Waste Reduction Center of the University of Northern Iowa, and they actually had a painter training course that looks promising. It was an online painter training course that featured detailed audio description of the processes, as well as some video demonstrations of both proper and improper techniques. And I thought that this would be a nice way to supplement the hands-on training, because this could help to accommodate different learning styles for newer painters, while also standardizing the process, make sure they're all learning the same techniques. And in fact, the EPA had published an article from the IWRC claiming that with proper training, your transfer efficiency with HVLP guns can increase by at least 12%. So 3P is currently planning on having all of their painters undergo this training. And applying that increase in transfer efficiency, I estimated that 3P could eliminate about 43,000 pounds of paint waste per year and save about $69,000 per year. And that assumes that turnover will decrease by just 1%. Hopefully it will decrease by more than that. And with a price tag of about $14,000, it would take 3P a couple of months to recover their investment. So but that's a relatively short payback period. And with the strong benefits this project has, it has been recommended. The next project I looked at was the covering of the process tanks. So before the parts are painted, they often go through a series of solution baths held in process tanks. And that helps to strengthen the parts and protect from corrosion. But none of these process tanks are covered. And some of them are heated to some fairly high temperatures, and you can see vapors coming off of the tanks. And that means we've got material, energy used to heat that material, as well as the costs associated with that are being wasted. So I recalled from training that there are several different options for process tank covers that can cover the tanks while they are not being used, but then open up whenever the parts need to be dipped in and then close after. So first I tried to approximate how much 3P could see in savings. I used the Surface Technology Environmental Resource Center, or STERC's evaporation calculator, using the tank's surface area, as well as the temperatures the fluid was being heated to. I assumed that with process tanks, 3B could save about 387,000 gallons of water per year and about $19,000 per year. Unfortunately, there are still a few considerations that need to be made. I had reached out to KCH Surface Finishing, one of the companies that can custom tailor these process tank covers, but the quotes for installation is still pending. So I do not yet have an approximation for installation cost or the payback period. And there are also, it's a fairly complex process. And I didn't have time to analyze all the elements. Some of the water used in the tanks, for example, is treated through reverse osmosis or RO. And that's a fairly energy intensive process. So actually the energy savings are potentially higher. So, but because there are already some strong savings to be had, I recommended that 3P continue to do research on this project and model it as best as they can. The third project I looked at was a lighting project, specifically the retrofitting of fluorescent bulb fixtures with LEDs. So when I was looking at waste manifests and purchase orders, I noticed that there were several charges tied to the disposal of fluorescent bulbs. And looking at electric bills, I noticed that there are some regions of 3P that are more energy efficient than others. And as you can see, the maintenance region, more often than not, has a power factor that's below the ideal 90%. And that compares the amount of electricity you're drawing to how much actually gets used. So 3P does still have fluorescent bulbs in many of their fixtures. They've been trying to replace them gradually with LEDs as the fluorescents are burning out, but I wanted to do some research and see if it'd be possible to do a complete retrofit. Unfortunately, many of these fixtures were pretty high up in the ceiling, so I didn't have access to them, but I did have access to purchase orders for equipment, so I was able to make some approximations from there. It appeared that the fluorescent fixtures used electronic ballasts to help regulate the electricity, make sure the fluorescent bulbs don't get too much. And while those are more efficient than the magnetic ballasts that exist, I noted that a lot of the LEDs that 3P was purchasing could either work with or without the ballasts. And removing the ballasts, since they do draw extra electricity, can help to improve energy efficiency and hopefully that power factor. And then I had to consider things like the purchasing of the new LED bulbs, the disposal of the old fluorescents, and there's a few other pieces of equipment like this orange wire connector that would be needed for the retrofits. So after crunching the numbers, I found that 3P could save about 143,000 kilowatt hours of electricity per year, but only about $7,600 per year. And with a cost of about $18,000 for installation, it would take 3P a couple of years to recover their investment on this project. But because there are some significant energy savings to be had, I did recommend this project, but I would first recommend implementing the other projects that have a shorter payback period and evaluating their success before considering a full LED retrofit. The final project that I looked at was a compressed air audit. 3P uses compressed air systems, and compressed air systems tend to leak, and those leaks can actually get fairly expensive. So with the help of another intern, I conducted a compressed air audit to help look for these leaks, and I was able to find them using an ultrasonic leak detector, and that works by pinpointing the location of the sound of the leaks, and it also tells its user the intensity of that sound in decibels. And the manufacturer of the device also produces an app that estimates the approximate energy and cost savings that could be had if you fix the leaks. All you need is the identity of the substance you are compressing, in this case air, the pressure you're trying to compress it to, which depended on the region, as well as the decibel readings from the audit. And after reviewing the findings with staff, just to make sure that the leaks found were actually leaks and not intentionally there, it was determined that there were 26 air leaks throughout 3P, and I have a couple of them photographed. This one on the left here is attached to the only process tank that uses compressed air, and you can actually feel air coming out of the patina region of the corroded pipe. And this one on the right was from one of the shop meeting rooms. As you can see, there's a pretty significant bulge there in the hose, and there was a tear near that. You could hear the leak coming out of that without the device, which is not a good sign. But after plugging in the data from those 26 leaks, the app estimated that 3D could save about 155,000 kilowatt hours of electricity per year, about $18,000 per year should all the leaks be fixed. And considering labor and material costs, it would only cost 3P about $365 to repair the leaks. So only about 3 weeks to receive the money back. And not only has the project been recommended, but at least 6 of the 26 leaks have been repaired. More have likely been repaired since then. So here we have a brief aggregate savings that 3P could expect should they implement the improved painter training, the LED retrofit, and the compressed air leak repairs. Not only could they eliminate the equivalent of 357 metric tons of carbon dioxide per year, but they could also save about $95,000 per year. Any questions?
I have a question for you, Max, or two.
Okay.
So, what I was looking at your online painter training.
Mhm.
Did you say it was $100 a painter to go through that training?
Yes, the online.
Online?
Yeah, if it was and that assumes it was going to be purchased for every single painter that was at 3P.
Okay, so there was like a group rate or something that got down to 100.
No, I think it's just $100 per painter. It was
Okay.
not a group rate.
What was the 14,000? I kind of read it wrong.
Oh, that.
Yeah,
So that includes the purchasing of the training, but there are also some labor costs associated with that. The painters are still going to be paid while they're taking the training course, which is estimated by the IWRC to take about 1.5 to 2 hours. So I use the 2-hour maximum just for a conservative estimate. I guess just in case the cost was the worst case scenario. And there's also some labor costs associated with the on-the-job training, since the painters will still probably receive some hands-on training from an experienced painter, so they will get paid for that as well.
okay, excellent. So thank you for answering that. Great job. I didn't catch that you included the labor costs. Great job doing that. And then that impact though, after all of the labor cost is 69,000
Yeah, because
a
there's.
year.
Yeah, because that would help. That's assuming that the rework and the waste disposal, those will all go down by I use the 12% from the increased to transfer efficiency, because if you've got more paint coming onto your parts, that's less paint that's being wasted. And that also included the 1% turnover decrease, which I think was about $4,000 of that. So even if the improved painter training has no effect on the turnover rate, 3P is still going to see some significant savings with the painter training.
I didn't realize that IWRC had gone to an online class, so that's really saves a lot of money compared to going up to Northern Iowa and doing that. And then how often do they recommend a refresher then? What are they? Was that included in this, or I was just curious?
That was not. I think the site say it was between
35 years.
Maybe. I thought it was more often than that, but
That's it. The NESHAP does require the 5-year, and it gives you a certificate. Does it give you a certification too?
yes, I think the completion of the course has a certification.
Excellent. Oh, that's great. Okay. I learned a lot new there, so thank you.
First of all, I apologize for the noise. I had my phone off and not my watch. On the online training, is it self-directed, do you know, or is it asynchronous?
Yeah, it's self-directed. So, but the outside supervisor and I did a test run of the online trainer course. So you just kind of go through each of the different units, and they actually have a quiz at the end. So you have to get at least 8 of the 10 questions right before you can advance to the next unit. So yeah, it's an asynchronous course that can be completed at their own pace.
Max and I both passed.
I do have one. So you mentioned that they have so many different parts, kind of like different shapes and different types of paints and everything. So what's done with the leftover paint normally? Is that something that is like, is it common that you can use the same batch of paint for another part?
So in the painting rooms, there are what's called water striders that help to facilitate the painting process. So I think they'll usually try and group up parts that are painted with the same paint so that the painters can just keep using the same paint and don't have to switch all the time. But
And like, but for example, if you had a batch and it was a specific paint, let's say they wanted it in pink, and then no other company wanted pink parts again. So do you know what's done with that leftover paint? Is it possible to donate this paint somewhere or resell it?
maybe, but a lot of the paints have expiration, and some of the paints come in multiple parts, so you have to mix them together before you can use them. And then once you mix them, then you have to use it within a certain time period before it expires. So unfortunately, the specifications get pretty stringent.
So you looked initially at 16 paints for the electrostatic evaluation. Of all of the more than 200 paints, did you pick those 16 specifically because they were the most commonly used paints, or was it kind of selected at random?
They were kind of selected at random. Obviously, I didn't have time to analyze all 250 specifications, but I think just from that brief analysis, I was able to see even just with one paint not being able to be painted with electrostatic guns, the painters would have to know which paints could be painted with which guns. And I thought it would just overcomplicate the process. But even if all the paints could be painted with the electrostatic, again, there's some other concerns like would the parts even be able to be charged, or since 3P automating their processes anytime soon.
There's nothing extra. Did you talk to the painters about how they feel about getting that training every once in a while? Do they like the idea?
I don't know. Some of the painters, I mostly talked to the more experienced painters when I was talking about painter training, but they did raise some concerns that especially the older painters are going to, they don't like being told, hey, you're painting wrong. So I think it would be best if because the IWRC course is actually designed more as a refresher course. So it might be better to approach the more experienced painters and say, hey, here's a brief refresher just to make sure. That would be good to have them go through that too. So then just to help make sure that all the painters are getting the same training, and that they can trust each other.
And I guess for that specific reason, it's a good way of like presenting the idea of the training. It will make a difference, because if you just tell them, well, we need to refresh your skills because they might be bad. People might not be very welcome of the idea. So, but yeah, training it's good for employees, feeling appreciated. So if you put it that way, it normally helps.
Yeah.
It's like we're investing money on you because we appreciate your work.
So just a quick question. I'm not familiar with prepping, because it's not going to take. If you give the LED pressure that you mentioned section 1.7.
Yes.
See. Can you expand on specifically how that would help these costs?
So I think how that works is it's mainly designed to help small businesses grow. So if they make investments in themselves, that can help them increase or help them succeed, then you can get a little bit of a tax deduction there. So it would just reduce the cost of some of the new equipment a little bit.
Question?
I'd just like to make one comment, Matt. This is the first time we ever had a summer intern. Max set the bar pretty high for us. I'd be open to doing it again in the future. And I didn't spend a lot of time with Max. We kind of let him go on his own. He'd come and ask questions. And he was pretty self-directed and motivated. We kind of pointed him in the right direction, and he took off and took the bull by the reins. So he did a great job, and we appreciate him being with us this summer, even though it's a day grant.
Thank you for sharing that, Terry. We really appreciate that feedback. So thank you. Great job, Max.
Good job.